Hello. Welcome to Big Boy Physics. Today I'll be discussing about IPHO problem 2 of 2006, which is based on special theory of relativity. I am opening the problem in front of you, which is watching a rod in motion. Okay, so this problem, see, there are basically few parts of this problem. So let me give you an overview. 2.1 to 2.2 does not involve that much of relativity. 2.3, from 2.3 onwards, you need the concept of relativity in your understanding. So let's get started with the discussion. The question says that a pinhole camera with the pinhole at x equals to 0 and is at a distance capital D from the x-axis takes the picture of a rod by opening the pinhole for a very short time. And there are equidistant marks along the x-axis by which the apparent length of the rod as it is seen on the picture can be determined from the pictures taken by the pinhole. So what happens basically that a rod is moving along the x-axis with some positive velocity, and at each instant we take the snapshot of the rod and we determine the length, or any parameter can be determined from the picture as follows. So now the concept of relativity comes here, that since the rod is not at rest but is moving with constant velocity v along the x-axis, so it means basically the rod will get contracted. That's the inference we'll get from it. Okay. So my first question is that the picture taken by the pinhole shows a very tiny segment of the rod. Okay. So we basically take a very point particle or a very tiny segment. Basically, it implies take a point only on the rod, and its position as shown in the picture by x tilde. Then you have to tell me the actual position x of the segment at the time when the picture is taken. Answer in terms of x tilde, d, l, v. Speed of light is c, and you can use these variables beta and gamma for your convenience to simplify your result. Okay. So this is my 2.1. Then 2.2 is about find the corresponding inverse relation, that is express x tilde in terms of x, d, l, v and c. And it's also to note that the actual position in the position the actual position in the frame in which the camera is at rest. Okay, so the camera is at rest and the actual position will find in the frame. So what's the idea behind the problem? Okay, so let me take the x-axis. This is my origin, and my pinhole camera P is located at some distance d from the x-axis. And consider my rod to be at x tilde. Rod's the point I'm observing to be at x tilde at a certain time. Now what happens? Well, basically that when the camera basically, how the camera basically generates the picture. What happens is that when the particle is at x tilde, it emits a light signal indicating that it's at x tilde. So the particle basically emits a light signal showing that it's at x tilde and reaches the camera. And reaching the camera will take a time of capital T is equals to under root d square plus x tilde square by c. Right? Now what will happen is, till the time the light signal reaches the pinhole, the particle travels by some distance and reaches to some other point x. Hence I can say that this x minus x tilde is equals to vt. Just plugging it into this equation, we'll get that x equals to x tilde plus v by c under root x tilde square plus d square. And that's the answer to my question. So the first question answer is that express x in terms of x tilde and other variables will come out to be x tilde plus v by c under root x tilde square plus d square, which you can further simplify as x tilde plus beta under root x tilde square plus d square. So that's the answer to my first part. So here is my solution to 2.1. Now coming to 2.2. For 2.2, what is my result? Actually, for 2.2, you just need to solve this equation and find x tilde. Let me take x tilde on the left hand side and square this expression. I'll get beta square x tilde square plus d square. And on further simplification, I will get 1 minus beta square x tilde square minus 2x x tilde plus x square minus beta square d square equals to 0. One thing I know that 1 minus beta square is equals to 1 by gamma square. So putting this 1 minus beta square equals to 1 by gamma square, I will get x tilde square minus 2x gamma square x tilde plus gamma square into x square minus beta square d square equals to 0. Hence now I have to just solve this quadratic. Thus I'll get x tilde is equals to 2x gamma square 2x gamma square plus minus under root 4x square gamma to the power 4 minus 4 gamma square x square plus 4 gamma square beta square d square upon 2. Just we need to simplify the result more. We'll get x gamma square plus minus under root x square. Now let me take gamma to the power 4 outside, or yeah, so gamma square in minus 4 by gamma square, sorry, 1 by gamma square x square plus beta square d square by gamma square. So we know that 1 minus 1 by gamma square is 1 minus beta square. Hence further simplifying, we'll get x gamma square plus minus gamma square under root beta x whole square plus beta d by gamma whole square. Now just a little more simplification. The final answer you get to be, sorry, my apologies. So this will be x now instead of x square, and final result will be x tilde is equals to gamma square x plus minus beta gamma under root x beta 1 minute under root x gamma whole square plus d square. And that's the answer to my second part. So now the one doubt still remains, that will it be plus or minus? So just a bit of logical reasoning. Think that x should be greater than x tilde. From the figure I can say that x should be less than x tilde. Hence, now if it was a plus sign, if it was plus, what would happen? That x tilde would be gamma square x. Already gamma is greater than 1, so this whole term will be greater than x. Plus minus, if it was plus, then it would be beta gamma plus some under root term, and this is also positive. So I would say that from here I can say x tilde will be greater than x, and this is a complete contradiction. So I will take the minus sign for this question, and I'll get x tilde is equals to gamma square x minus beta gamma under root x gamma whole square plus d square, and that's the final answer. So you may check the first two questions answer, and you'll get that yeah, our answer pretty much matches with the IPHO's given answer. So yeah, so that's the answer to my first two questions. Now next two questions comes to the point where we need to introduce relativity and Lorentz contraction for solving the question. So the question says that a pinhole camera takes the picture at the instant when the actual position of the center of the rod is x0. So my actual position of the center of the rod is some x0, and that time I get a picture, right? You have to tell me the apparent length of the rod in this picture. Okay, got it? So 2.3, we need to introduce some relativity concept. So let me just give you a brief introduction to what happens. Basically, when a rod moves with velocity v, its length gets contracted by a factor of gamma, and basically its length becomes L by gamma. So that's the key concept involved here. So basically when the rod moves, the length observed won't be L. Length observed will be L by gamma. So let's talk about 2.3 now. So as it said that when the picture is captured, it was seen that the rod's midpoint is at x naught. So if I draw the x-axis and this is my rod, so at this moment the midpoint is x naught. I can say that the right end xr can be written as x naught plus L by 2 gamma. Similarly, left end is equals to x naught minus L by 2 gamma. Right? It's the basic observation. Now, what will be the images of the right end and left end as captured by the camera when it initially emitted light? Okay, when it initially emitted or gave out light signal for the picture, what would have been the positions of the right end and the left end? So I can say that XL tilde basically defines the position x coordinate in the pictures. In the picture, what will be the observed x coordinate? So I can write XL tilde is equals to gamma square XL minus gamma beta under root gamma XL whole square plus d square. Similarly, XR tilde is equals to gamma square XR minus gamma beta under root gamma XR whole square plus d square. If I find this, just find the difference, XR tilde minus XL tilde will basically give me the length of rod in the picture, and that will come out to be gamma square into XR minus XL minus gamma beta under root gamma XR whole square plus d square plus beta gamma under root gamma XL whole square plus d square. Now just simplifying this result, you know XR minus XL will be L by gamma, hence you'll get L gamma minus gamma beta under root. What is gamma XR? Gamma XR is gamma x naught plus L by 2. So you'll get gamma x naught plus L by 2 whole square plus d square minus beta gamma under root gamma x naught minus L by 2 whole square plus d square. Okay, so that's my result. 1 minute, this will be a plus sign, apologize. So I'll get the length of the rod to be some number expression like this. Okay, so that's the answer to 2.3, quite large expression. Now coming to 2.4. 2.4 is about some multiple choice question. You have to check one of the boxes in the answer script and show how the apparent length of the rod changes with time. Okay, so let's see the options. The length first increases, then reaches a maximum value, then decreases. It decreases first, then reaches a maximum value, then increases. Decreases all the time. Then the fourth option is increases all the time. Okay, so yeah, this question you have to do some graph analysis. 2.4, like if you see the graph between x tilde x and x tilde, x versus x tilde graph, you already got one relation previously, that x equals to x tilde plus beta under root x tilde square plus d square. So if you find dx by dx tilde, you will get it to be 1 plus beta x tilde by under root x tilde square plus d square. So what can I infer? That as x tilde increases, my slope increases. Slope increases with increasing of x tilde, because this is some x tilde by under root x tilde square plus d square. Initially it will be, means when it's x tilde is very large negative value, so my slope will rise from 1 minus beta to some x tilde to be very large positive value, that is x1 plus beta. Hence my function will be somewhat like this. I expect my function to be somewhat like this. Yeah, so my relation between x and x tilde should be somewhat like this. It will be a convex function. So I don't think you need this portion. Let me drop this. Yeah, So basically my relation between x and x tilde will be a convex function like this. Now what will happen basically, you imagine the rod to be of a constant length along the x coordinate, that will be L by gamma. Now in this L by gamma, if you just take the projection of this on the x tilde axis, so this length will basically give me the length of the rod in the picture. So this L prime will be the length of the rod in the picture. Hence, what can I say, that now as rod goes to the positive x-axis, the x coordinate rises. Thus this length basically, if you draw a line joining the endpoints and consider it to be theta. So if my left end of the rod, suppose it's at xl, as xl rises, you can say that theta also rises. This is a basic observation. Like if xl rises, then theta must rise because it's a convex function, and y difference is constant. Thus, you can say that the length of the rod in the picture, which is L by gamma upon tan theta, will decrease. This implies that my length of the rod always decrease with time. So that's the answer. My answer is it will always decrease with time. So option C is my answer. You can also check the official answer key that says the apparent length always decreases with time. Now IPHO has also given another nice answer, that see, this square root expression, this expression has a this square root expression, observe the square root expression, this actually decreases with time constantly. So you can also infer from that. So that's another way to think. Another way, you can use some I'd say rather tukka strategy, like take the length of the rod to be very small and try to analyze what will happen. So that's another way. So but I find this way more convenient to explain as well as understand, so I explain this way. So that's the first half of the problem solving. So stay tuned. I'll be uploading the second part soon. Thank you.